When you are counting or adding or subtracting, you are performing an operation, not the kind that doctors perform, the kind that mathematicians perform when they do ornament. The word ornament comes from ancient Greek and means the art of numbers. It is used in addition, subtraction, multiplication, and division, which are known as the four operations. Square root 2 cannot be written as an this number that begins 1.4142 and goes on forever. Some people believe the number 13 to be real and lucky. Another way to think of fractions is a division calculation. If you use the cake example, 1/4 tells you to divide one cake into 4 pieces. If you type 1 divided by 4 into a calculator, the answer would be 0.25. This is what is known as a decimal fraction, or more commonly, a decimal. If you put 1 divided by 3 into a calculator, the answer would be 0.3333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333, which goes on forever. This is called a repeating decimal. To save space, they are written with a line over the recurring part, so 1/3 is written as 0.3 line. Sometimes a number will have lots of digits after the point. For example, the number 0.4567 has 4. This is called working to 4 decimal places. These numbers can be shortened by rounding up or down. If you want to work the 2 decimal places instead, you would look at the digit in the 3rd decimal place. If the digit is equal to or higher than 5, as with 0.4567, you would round up to 0.46. If it is less than 5, as with the number 0.6543, you would round the number down to 0.65. Another sequence that can be applied in nature is known as the Fibonacci sequence. It goes like this. It goes like this. 1, 1, 2, 3, 5, 8, 13, 21, 34. There is a simple rule to make this sequence. Can you see what it is? The answer is at the bottom of the page. Does infinity mean anything? Well, it might, because you might live in an infinite universe. If that's true, there may be an infinite number of stars. If just one in a trillion stars had a planet similar to Earth orbiting it, that would mean there would be an infinite number of planets like Earth. Because a trillionth of infinity is infinity. If there are an infinite number of planets like Earth, there must be an infinite number of planets with humans living on them, and an infinite number of those humans must have your name, your age, your parents. There must be an infinite number of people just like you. It's enough to make your head spin. I told you we went the wrong way. We passed our Earth 2 galaxies back. If you want to find the height of something very tall, you need a long ladder and a huge tape measure, right? Wrong. All you need to do is find a long straight stick and something to measure. A nice tall tree, for example. Push the stick into the ground a little way from the tree. Next, find a position on the ground where the top of the tree lines up with the top of the stick from your point of view. This will make two triangles, one from your eye to the stick, and one from your eye to the tree. They both have the same angles, even though they are different sizes. These are known as similar triangles. The lengths of each side of similar triangles are also in proportion. With a few simple measurements, you can use this to work out the tree's height compared with the stick. If you tried to triangulate a star using the same baseline as above, it would be too narrow because stars are so distant. There's a clever trick to increase the triangle's size, though. By measuring angle A first, then angle B 6 months later, when Earth is directly opposite in this order, the distance between points A and B will be double the distance to the Sun. Using this interstellar-sized triangle, you can work out the distance to the star. Simple. Simple regular polygons such as squares or rectangles are easier when it comes to calculating the amount of space that they take up. Just multiply the length by the width. For square measuring 4 inch by 4 inch, you simply multiply 4 times 4. The answer is 16, so the square has an area of 16 inches. A rectangle that is 4 inches by 2 inches has an area of 8 inches. Equally, if you want to know the distance on the edge of your square or rectangle, its perimeter, you just combine the lengths of all 4 sides. How would you measure a circle, though? There are no sides for you to multiply, and sometimes it would be really useful to be able to figure out a circle's area or its circumference, which is the special name for the perimeter of a circle. The answer is a lot simpler than you may think. For centuries, people know that for any circle, the circumference is just over 3 times the diameter, which is 3.14. The distance across the middle of a circle. This ratio is the same whatever the size of the circle. As time went on, people improved the calculation. And in fact, the circumference of a circle is more like 3.141592654 times the diameter. This number is called pi, which can also be written with the symbol double T, and is often abbreviated to 3.142. It is another rational number, see page 19, and it actually goes on forever. Circumference 3.142 times D. To study shapes that are more complex than regular polyhedrons, topology is used. Topology studies what happens to shapes when you squash, stretch, or twist them. When shapes be stretched or twisted to make another shape, they can be described as topologically equivalent. For example, a donut and a needle can be described as topology equivalent because they both have a hole going through them. Neither can be described as a topology equivalent to a glass, however, as a glass does not have a hole going through it. Topologists have made some rather weird discoveries about shapes. For instance, three-dimensional objects are thought of having an inside and an outside. But in 1858, the German mathematician August Möbius created something that had just one continuous surface. It is known as the Möbius strip. You can make your own Möbius strip crazy. You take a strip of paper, twist it once, and stick the ends together so that it looks like this. Take a pen and draw a line along the middle of the strip without lifting it off the paper. Your pen will cover every bit of the strip, then come back around to meet your starting point, proving that the Möbius strip has just one surface. One-dimensional shapes can't really be seen either, as they are just lines with no thickness. However, in mathematics, it's normal to imagine that lines are just thick enough to allow them to be drawn. So here is a one-dimensional shape. By extending it sideways, you can make a two-dimensional shape. Here it is, a diamond or a rhombus. If you add some vertical lines and another rhombus, it becomes a representation of a three-dimensional shape. a rhomboid. What about the fourth dimension? How would that look? To look at the fourth dimension and beyond, imagine a square. A two-dimensional square is made with 4 lines. A three-dimensional cube is made with 12 lines. The next square shape in the fourth dimension has 32 lines and is known as a tesseract or hypercube. The best way to think of a tesseract is imagine 2 three-dimensional cubes attached to each other so that every face of the cube becomes a three-dimensional shape like this. Did you know time is also a dimension? You travel from morning to night just as you travel to and from school. Although, of course, reversing, turning, and stopping in time isn't possible yet. Time and space are always linked. They are known as space-time. The best-known scientist to work with space-time was Albert Einstein. He discovered that when things travel really quickly, they change shape. Imagine that there was a big bomb traveling through space. Einstein proved that if it was going fast enough, it would change shape like this. Another part of Einstein's space-time theory said that time passes at different rates depending on how the person measuring it is moving. If you were unfortunate enough to be on the bomb, you might measure the time for its fuse to burn down as a minute. If someone on the ground watched you whiz past and time the fuse too, he might measure it as taking 2 minutes. To look at it another way, imagine a spaceship traveling at nearly the speed of light. If the astronauts on board traveled for what they measured as a year, they would find that far longer would pass on Earth when they returned to Earth, perhaps thousands of years. No! They demolished the pizza place! An extra dimensional. Does the world really have just 4 dimensions? Of course not. That would be silly. In reality, scientists think it has 11. M theory, the idea of 11 dimensions suggests that 10 dimensions are of space and 1 is time. How come no one has ever noticed all these extra dimensions, though? The answer is that they are scrunched up too small to see. Perhaps this is just a 10-dimensional equivalent of a cube called a decorax is made up of 5,120 lines. Imagine that. Space War the Third, now in 10D. Did you know? Einstein's theories also say that the speed of light is the fastest thing possible. Until very recently, everyone was still something that was true. However, scientists in Switzerland, the European Organization for Nuclear Research, also known as CERN, discovered that it might be possible for tiny particles called neutrinos to move faster. Perfect symmetry. Many shapes and other things too have symmetry, which means that if you were to cut them in half from top to bottom, the 2 halves would be similar, if not identical. Even people have symmetry. If you were to draw a line down the middle of your body, from the top of your head to your feet, the 2 halves would be very similar. The line you drew down yourself is called an axis of symmetry. Many regular shapes have several axes of symmetry. This square, for instance, has 4 axes of symmetry. Can you work out how many axes of symmetry a circle has? The answer is at the bottom of the page. Take a mirror and hold it at a 90 degrees angle against a photo of your face along the length of the middle, so that the left side of your face is reflected in the mirror. Turn the mirror and repeat it with the right side of your face. Do the images look similar or different? The more similar the images are, the more symmetrical your face is. Mirror, mirror on the wall, who's the most symmetrical of them all?